Hello, good afternoon. Good afternoon to all of you that are here and that are also to all of you that are watching through the streaming. So my presentation this afternoon, which is Threats and Concealment of Wi-Fi Communication in Urban Environments, describes a little bit all of the things that I want to show you today, even though the title is a little bit long. As you know, Wi-Fi technology is widely spread nowadays. There are a lot of threats, a lot of attacks. So my presentation is an educational presentation for you to know some of the threats that there are right now outside. Maybe you have heard of some of them, but also I want to talk about other alternative communications that have emerged. And this is also quite educational too. If you want to learn how technology is working, the best thing you can do is experimenting and trying, and this is how we are going to be able to find new things. So my presentation will have three parts. First, I'm going to talk about the main Wi-Fi network architectures nowadays, and I'm going to focus basically on their working characteristics, their functionalities. Then the second part will be weaknesses and threats of Wi-Fi WPA2 networks, which are quite widely spread too, and they are more secured. I will talk about service denial attacks, which are very common attacks that may cause a lot of problems and are very difficult to mitigate. And finally, in order to get to know how... Sorry. So in order to get this network works and what we can do, I'm going to show you how to have some more original Wi-Fi connections that are more hidden and that also can offer many opportunities. So regarding Wi-Fi networks, we're going to talk about personal Wi-Fi networks, which are called WPA2 PSK. And these type of networks are all the Wi-Fi networks that we have. I mean, these are that we have in our homes. These are the networks that our service providers are offering us with an Ethernet cable and an access point, which is the device that will allow us to configure a wireless network and through which we will be able to access to the internet. So, personal Wi-Fi networks work based on access points. As I've said, access points are the elements that are going to connect my wireless network with the internet. This access point will be within our Wi-Fi server. And as you know, every wireless system may be intercepted. There is no privacy here because every electromagnetic wave is going to spread throughout the space, and if our Wi-Fi sensor is very sensitive, we will be able to gather these waves from farther away. This Wi-Fi also is based on a wireless networks. This is based on a network identification with a character chain of 32 characters, and well, this is not a problem, but at some points maybe we will need to know that the characters will be repeated or not. Regarding our households, we will need to have an authentication point and an access key. These connections are authenticated. This means that every device can connect to the wireless system. There is something called passphrase, which is a combination of letters or numbers and specific symbols that could be used as access key. Through this access key, we will see that these are the keys that will encode the communication. So also we are using an algorithm here, which is CCMP algorithm based on AES, and which is based on a key of encryption of 128 bits. These keys are generated through process name four-way handshake, which I will mention later. So which problems do we have with these wireless networks? Every user have a Wi-Fi point of access, so there's a problem of saturation. Every wireless communication need to send an electromagnetic wave in order to send data, but in this case, we are using different frequencies for this communication. So nowadays we are using the band of 2.4 gigahertz and sometimes 5 gigahertz. What's a band? A band is a set of frequencies. So in the case of 2.4 gigahertz, we have 13 communication channels that could be used in our wireless communication channels or networks. Therefore, there is a problem regarding interferences. If I have 50 neighbors in my building and we just have 13 communication channels, some of them may be repeated, and this is why we're having sometimes interferences that are going to hinder the functioning of our network. So in order to improve this functioning, routers can choose the channel, the Wi-Fi channel that they are going to use for the wireless communication by looking at the areas where there are the least number of connections. But when we have a saturation, we are going to look for the best spots. So a house can configure a fixed point of access for the Wi-Fi, and the rest of the connections are going to try to find the second best spots in order to not be so close to our neighbors. Other type of networks that we have are corporate networks that aim to solve a more complex problem. We're going to have more users, of course, here than in a personal set of networks, and we are also going to have a big space in which we are going to establish our communications. This means that, for example, basic working distances are about 100 to 100 meters, but if we are talking about a university campus, distances are going to be greater. So these enterprise networks aim to set different points of access in different points of that area to cover greater areas. So if we cannot cover this area with just one point of access, we will establish several that connect to the main cable or of the company. This type of networks offer a more secure connection because we are going to use more specific authentication points. In a building, all of the users of a house will use the same password or the same authentication, but in these enterprise networks is going to use different authentication in each user. Once the user has been validated or authenticated, we are going to use two encryption mechanisms that use a key of encryption that may not be generated based on the same value. So the main difference will be that in enterprise, encryption keys are generated through a random value which is individual to each user. So therefore, they are going to be more resistant towards attacks. Also, we are going to have less interferences because these networks domain big areas, and they are tailor-made. So we are going to be able to reduce the number of interferences. It's not the same as the building full of houses and neighborhoods that we've mentioned before. And then we have public Wi-Fi networks, which are open networks to the citizens, so anyone can access this type of communication networks. For example, this is the type of networks that we have in hotels, in restaurants or malls, and the main characteristic is that they do not have any security measure. So the Wi-Fi symbol, as we can see on the screen, do not have these the security item. So what can we do when we have an open Wi-Fi network? We cannot use it as freely as other type of networks, but sometimes we are going to use them. So the recommendation would be to use this type of networks for specific things in order to avoid to avoid having security problems, that our conversations are intercepted, etc. We should use VPNs in order to protect the communication, but anyway, our device is going to be accessible. If someone is sending packages, the device is going to process it. So all the weaknesses of a mobile phone, for example, could be exploited when using this type of public Wi-Fi networks. Also, I want to mention the Wi-Fi for EU, which is a project of the European Union that is funding the installation of public and free Wi-Fi networks all over the European Union. In Spain, for example, there are several projects in cities in which the EU has decided to cover and to provide Wi-Fi networks in that cities. So how are these these free networks? There are two phases of deployment. In the first deployment, we are going to use networks similar to open Wi-Fi networks without encryption or authentication, and we must be careful because we must be exposed to any type of attack. But there is also a second phase in which these points of access will be modified and will use the authentication method of the enterprise network, which is IEEE 802.1x. So every citizen will have his or her own point of access. So this is a brief summary in order to give you some context about the different networks that we have. And now that we know the type of networks that we have, we're going to see the different weaknesses and threats that we may face in each networks. We have to talk about the brute force attacks that have been specifically addressing to these WPA2 PSK networks. So in this type of networks, usually there is a connection process between the point of access and the user. Normally, you need to establish a key of encryption in order to use a private connection with the four-way handshake procedure that based on a passphrase will obtain another key, which is the PTK, pairwise transient key. And one of the keys that it contains is the key of encryption of the packages of the client. So if someone knows the password of the Wi-Fi, he could generate an encoding key that will be only valid during the session. If I connect later, we are sorry, but the sound is not working. We are not receiving any sound from the auditorium. We've had a small issue, but we've already solved it. Sorry for the inconvenience, but we're getting back. Well, so after this failure, which has not been a cyber attack because we are in CyberCamp and we are very aware of that. Well, I was mentioning all the encoding keys that a user needs to establish when he or she connects himself or herself to a Wi-Fi network. But everything starts with the passphrase that I've mentioned before. So can we decode that information? Here we have a screenshot of that is capturing the information that is arriving. So we are not going to see this in detail, but these are communication packages that are hiding the information that they have inside because it is encoded. This has been done through a key, the key AES. And this AES key can be obtained through the passphrase. If I have the passphrase, I would be able to visualize all the communication packages. And not just my communication packages, but the communication packages of all of the users of that wireless network. And for example, there is a free analysis software called Wireshark that, through a screenshot of encrypted communication packages, to obtain the information. We just need the passphrase, the Wi-Fi key, and the AES, and this four-way handshake, which is the initial exchange. So if I have all this data, I can introduce the data to the Wireshark application, and next, we will be able to visualize all the decoded packages that have been captured. So if we have the fact of having a Wi-Fi network with a password doesn't mean that it is secured. We already knew that communication was not secured in open Wi-Fi networks, and this is why some malls and some hotels were starting to add some passwords to that connections. But we have the same problem. If you know the passphrase, the password, you're going to be able to intercept these communication packages as we've seen. So how can we discover this passphrase? Well, there are experimental ways to obtain this passphrase, for example, brute force, because all of the encryption systems are going to be based on a key. If I can try all of the keys, I'm sure I'm going to end up finding the one. But the thing is that it takes time. However, it's true that we can kind of intervene in this procedure. And when we have devices that are connected to a communication network, these devices are going to create these four-way handshakes. We can capture these packages, and then we can try all the possible passphrase combinations. And these combinations do not really mean every combination. We are having a passphrase, and we may think that a user has used words that are easy to remember, characters that are in the laptop. So in the end, the number of combinations is not that high, and we can use these brute force methods with text dictionaries, books, and I don't know, different files with password of users that have been discovered. With all these, we can try all this combination of keys, and if we are lucky, in a reasonable amount of time, we may find the one. This is at least how things worked before. We needed to at least visualize the four-way handshake. But what happens if there is no device connected to the network? These four-way handshake are not going to happen, but lately we've seen that this four-way handshake contains an information called PKMIT that also allows to obtain the passphrase during brute force mechanism. So with access keys or access passwords, passphrases, and four-way shake, we are going to be able to obtain all the information that we need. And what happens if someone finds out what my passphrase is? Because what the most frequent problem that I may find as a normal user in my house is that probably my neighbors will get free Wi-Fi. The thing here is that people would also be able to intercept my communications, and someone would be able to know what I like, which sites I visit, etc. This is why we have to protect carefully our passphrase. And also because we need to take into account how my Wi-Fi network works at home. Normally, this is an accessory that we use in order to access the internet on a flexible way. So all the equipments that there are in my Wi-Fi network are going to connect to the internet by just registering the IP direction that my internet router has. So all the traffic that is generated in a house and the control information are going to take place from the IP address of the user. So if someone commits a crime using my IP address, I'm going to be the main suspect for that, or at least the person that has signed the internet agreement is going to be the suspected person. So the most simple solution would be at least to use a complicated password. This at least would avoid that we would have to go to the police station to give explanations about something. So how can I protect my passphrase? Well, I don't have to share this passphrase with anyone, or at least with not a great number of people. And sometimes also providers offer like a password for guests that may be valid just for some hours, and that afterwards will not work anymore. The passphrase should at least have at least 20 characters, because otherwise, in some months, anyone could obtain the access passphrase of that Wi-Fi network. And we also should change our Wi-Fi passphrase from time to time, because at least we should have a passphrase with at least 20 characters. Besides that, we should use another encryption method, such as, for example, the use of VPN connections. Can we use also these solutions for enterprise networks? So theoretically, it would be possible, because the enterprise systems use the same mechanism, the four-way handshake, in order to create the encryption key. But it is true that this encryption key is not generated through a value which is easier to find out. How is this generated? We will see later that in enterprise systems, when the user needs to authenticate himself or herself, a random key is going to be sent, and through this random key, another key will be generated, will be the encryption key. So the process here is more complicated. In the end, the encryption key is a value. It can be generated through brute force, of course, but with this PMK system, this is going to be harder, because we are talking about a binary system that is going to take longer, and that is going to be more complex. So what are the consequences if someone finds out the PMK? Well, the communications that are going to be found out are only communications that are specific of a moment of time. And this is not going to compromise the fact of other people connecting to that network. In personal networks, the process of connecting is very related to the password, to the passphrase, but it is not the same thing with enterprise systems. However, brute force attacks are very well known, and we are going to talk here about the authentication attacks to WPA2. When I want to connect to a Wi-Fi network, there is a process of connection and deconnection. And this implies the exchange of different packages, 6 packages at least. So first, we look for the point of access. Then once we know what the point of access is, I'm going to send a prof request, then a prof response. And then the communication is controlled after that connection. After that connection, this is where all the packages that I've mentioned before are going to be exchanged. If we are having a WPA2, we are going to have the forehand handshake. And if we're having an enterprise WPA2, we're going to have PAP, the authentication, four-way handshake, and then the encryption data. So when does this communication ends between the point of access and the device? When the disconnection happens. This disconnection is going to take place by the mobile device. Either I can connect to the Wi-Fi network or I can disconnect when I've finished doing my thing. However, this disconnection may also take place from the point of access. So sometimes the points of access can be saturated, or maybe a device is getting farther from the point of access. In this case, it's possible that the point of access sends the disconnection or the authentication packages. The control of that is very simple. So when I have this authentication package that goes from the point of access to the mobile device, the package is going to be processed. There is no control there. So that's the weakness that we may find. The addresses of devices in wireless networks have 48 bits, and these values of 48 bits are transmitted in the wireless network without any coding, any encryption. Because if they would be encrypted, they wouldn't be decoded.
How can we use these deauthentication packages without having any problem? We have the non-persistent deauthentication. In this non-persistent deauthentication, we send deauthentication packages to a device which is connected to the access point in order to trigger it to have the four-way handshake, which is the one that enables me to have the access key for the Wi-Fi. So an attacker here would have to generate deauthentication packages which are correct enough. We will see it afterwards, and it causes that the device disconnects because it thinks that the access point is telling it to disconnect. When it tries to reconnect, it is when we have the four-way handshake that allows me to derivate my access key if it is a bad one. If it has 20 characters, we wouldn't have any danger because at the short term our access key couldn't be figured out. There is another deauthentication mode, which is the persistent deauthentication. Instead of trying to activate the four-way handshake, we're going to try to cause harm. So we are going to be continuously sending persistent deauthentication packages so that the device is trying to connect all the time. After a while, the device has reached the maximum of attempts of connection, and in the end, the communication is going to be broken. So the user won't have any Wi-Fi connectivity. So we have caused a denial of Wi-Fi connection. What happens in WPA2 Enterprise systems, this persistent deauthentication could have an effect as well. These kind of systems are better protected because there are several access points. At a certain point, one mobile device connects to this network and an attacker sends persistent deauthentication packages in order to try to prevent the connection. So what does the device do? It tries to connect through another access point, and at this point, the attacker cannot do anything else. So they would need to change the place, the position, in order to send other packages. However, they will need to send other packages because the MAC address of the access point is different. These attacks to WPA2 enterprise systems are feasible, but their effect is not as important because due to the fact of having different access points, the attacker needs to attack all the users, all the access points, and so on. Let's talk about how to take this into practice, which is creating our own deauthentication attack. In order to create these kind of attacks, we need something as simple as generating wireless packages. How can we generate this kind of packages? I follow the rules, or I use my network monitor in order to check manually which one of them are the authentication packages. The most important thing here is the MAC address of the access point and the mobile device that we want to be disconnected. With those data that we can collect just from observing the network, we would have all the information we need to carry out this kind of attacks. To attack DOS, we need a hardware of communications, which is a chipset, a Wi-Fi chipset with monitor mode, which is a functioning mode of chips that enables us to read any chip and to transmit any package in any format. One inconvenience of these kind of attacks is that they require physical presence. I cannot do it remotely from Japan, for example. So if I don't want to be seen, I need to be a bit far away. So in this case, people use high-level Wi-Fi antennas. This hardware needs to be managed by an operating system and CPU, and we would just need a simple Raspberry Pi with a Linux system, which will enable us to send packages at a speed fast enough to carry out the attack. And finally, we have the programming of the delivery of these kind of packages. There are several tools on the market in order to carry out this kind of attacks and to detect them. But I want to suggest you creating your own packages with just 50 lines of code, which enable you to exploit this kind of problems and to visualize them. This will make you understand any communication systems. So to create your own tools is also important. What have I done? Well, I use C language, and we also have some libraries such as libcap, which enables us to read information from a wireless communication system and to transmit. When I talk about wireless communication system, I'm talking about any of them. And how does this demonstration work? Well, now I'm going to assemble a Wi-Fi network with that identifier, with that passphrase, which would be very easy to, it is very weak, so it is very easy to figure out. This is the access point that I'm going to use. It has a neutral, it is neutral, so it doesn't have access to internet. Any device which is connected, we will be able to see the data exchange. Here you also have the tool that I showed you before, a Raspberry Pi with Wi-Fi, which will enable me to see what devices are connected, and we can disconnect some devices in a selected way. That's what I'm going to do now. So that first I'm going to connect to this Raspberry Pi, where I have all the software in order to capture packages and to be able to disconnect devices.
La primera herramienta que tenemos que desarrollar es un pequeño programa que lo que haga es nos analice.
First of all, we need a program that analyzes which devices are connected to that Wi-Fi network. First, I need to know what Wi-Fi network is there. So I'm going to use Linux in order to know what Wi-Fi networks are in my environment. So I'm going to include the data from the Wi-Fi network that I just created. What data do I have from this network? I have the MAC address of the access point, which is this data here, the channel, which is the channel 7, and the name of the network, so that we can program a tool called MAC search. That tool introduces as parameters the interface where we want to look for devices, the access point, which will tell me what devices are connected. This is a procedure that takes a while because it waits for a device connected to that network to transmit some packages. Yes, I see you are participating actively. So these are all the devices associated with my access point. I'm going to access this access point. Here it is, I couldn't find it. So here we have the Wi-Fi network icon, which will show that we are connected. And from my PC,
Si me permite conectarle, porque os habéis conectado tantos que hasta mi propio punto de acceso. Bueno, vamos a intentar a ver si me deja conectarme.
Well, meanwhile, I'm going to show you the tool of the service delegation. This tool enables us to generate those deauthentication packages. And what do we need? We need to enter the name of the interface and the channel where the communication will be made. So these are the parameters: the Wi-Fi interface, the channel, the 7th, and the access point. So this tool will allow me to enter MAC addresses, and that MAC address can be deleted. So I can withdraw the MAC address that I am denying. Well, it's taking a while for my PC to get connected. Let's see how many we have. I have a couple of mobile devices here.
Este dispositivo es uno de los teléfonos móviles que tengo ya aquí. Este dispositivo, si ahora os conectáis a alguno
If anyone else gets connected, then it will enable us to see the Wi-Fi icon as if I were connected, and when I send the deauthentication packages, that Wi-Fi icon will be disconnected.
¿Qué va a pasar cuando estemos denegando ese dispositivo?
And what happens when we are denying that device? If the device is connected, the icon of Wi-Fi will disconnect itself. So this will disconnect all the devices in the network.
Bueno, voy a continuar con la presentación para haceros otra demo.
Okay, I'm gonna do another demonstration, and if we have more time, in the end, I will continue on this deauthentication package. How can a denial of service attack be used? They will disable a network at device level, so we can select devices or we can block all the devices within that network. It has one main limitation: physical presence. On many occasions, the attacker doesn't want to be exposed. Most of denial of service attacks aim at reputational harm. In other words, to block a network so that that enterprise, that company cannot offer services to their clients. They could manage to have a device, only device that can have access to all of them. Another attack is made to smart houses, because we are increasingly adding more Internet of Things at home, so if it is attacked, we could have harm on our house. And where could we effect a harm, economic harm? Well, to those companies whose business model is based on a wireless communication. For example, in some restaurants, waiters use a tablet with Wi-Fi connection in order to connect with the system of the restaurant, and in this case the harm will be high. Obviously, the attacker has to build an infrastructure in order to stop the network. Imagine this happens a Saturday night in a restaurant where the kitchen needs to work at a very fast speed, and if the network doesn't work, the staff won't probably know what to do. So then they will need to go back to take orders in paper in order to solve the problem. If in that crisis situation somebody offers their help, we would accept it. And then it's what we call the miraculous call. The internet operator calls us and tells us that there is a problem in our communication system. Unfortunately, the functioning of the company makes them to take a while to solve it, but they are offering an extra service where a technician can come to the restaurant. Probably in that crisis moment, they will accept it and the operator will come. The attacker will come, will make everything, will solve all the problems, and that's where the attacker gets some economic benefit. Obviously, their exposure here is higher because they are they expose themselves. They go physically. Today, WPA2 systems are quite unprotected because there is no rule to incorporate a protection mechanism. But until the moment when we have WPA3 systems with protection, we will have some vulnerabilities, and then what we need to do is to create a tool in order to detect the authentication packages, and if there are many of them, that means the network is not functioning correctly. Okay, my PC is already connected, so let's continue with this. And I can send pings to the access point, so it is going to reply. Oops, sorry. The parameters of the wireless network may have changed. We are in channel 1 now, so we do the same. We look for MAC addresses in channel 1, and we see some of them already on the screen. The one from my PC. Let's see if I can find mine. Okay, I automatically disconnected. I'm going to show you the last presentation because I do not have a lot of time ahead of me. This is one of the most known attacks. This is called camouflage, the hiding of Wi-Fi networks. If we avoid the connection process, then these kind of attacks could not affect us. Is it possible to transmit wireless packages without being connected to a wireless network? Yes, under some conditions. The information has to be limited. In the Internet of Things, you need to exchange some small amount of data coming from the sensors. And what does it involve? We need to transmit packages that can be processed by any device. Those packages are the control packages from a Wi-Fi network with one special feature. There are some special packages called beacon frames, which will enable us to transmit big amount of data. Those beacon frames inform about the features of the access point, the name of the network, the SSID, the speed, channel, and so on. So these packages are sent from the AP to all the machines within the network. They can be processed by any chip, and they are incorporated in a structure with a code to indicate the code, the length, 9 bytes, and the name of the SSID. And what does this mean? In beacon frame packages, we can add additional tags. I can use a tag which is not being used, such as 255, and I can introduce the amount of data that I want. This will lead to hide our data communication. And how does it work? Okay, we have an access point that from time to time changes the beacon frame. In the middle of that communication, we can enter very similar packages with different amount of data, the data that we want to transmit. And what can we do with this? At some point, two devices can exchange these packages and exchange data, but data at a very limited level. For example, we can have a chat system where two devices exchange text messages which are incorporated into beacon frames which are very similar to a Wi-Fi in the environment. So with this, we're going to be able to hide them at a certain level. Those packages can be seen, so we need to encrypt those data, which in this case has used the AES encryption. And as a result, we have packages between two devices using an access point, and they are going to use the format of the AP beacon frames in order to exchange ours. What are we going to detect in that communication? We're going to detect a lot of beacon frame packages. Some of them will incorporate our data. How to discriminate, how to distinguish them? Well, it is a very tedious process. All the all the access point packages have a frequency number. Ours are not going to have the same sequence number. Another thing to distinguish them is the size. If they carry more data, they are going to have a bigger size, so we could detect them by size. But at first, that communication could be performed. Okay, this is my last demonstration. I hope not to have any problems. In this demonstration, I am going to use the Raspberry Pi with an app called Hidden Chat. This application transmits beacon frame packages with messages that I am going to introduce. And in my PC, I'm going to use the same application in order to send those data. So the parameters that this application needs are the data from the Wi-Fi network, which is going to be used as a transportation vehicle. Let's say the user is Luis with interface WLAN0 with channel 1 from the AP and the address, the MAC address, and the SSID, which would be Wi-Fi, JBG Wi-Fi. Okay, so here we would be ready to send a message as a beacon frame package, which is similar to the access point package. Here we would do the same, but let's change the username. Let's say Elena. So, from the moment we start sending a message, on the other window we can see the message. Hello. Just a second, because I want you to see the packages that I have just exchanged. Let's start this and let's send a couple of messages. I don't know if I will be able to capture anything because it was halted. Let's see the beacon frame packages. I'm going to order them. Yes, I just wanted to show you what these packages look like. If we order them by size, which is the easiest way to find them, we see there are two packages here. Oh, I didn't have enough time to capture them. Okay, I'm running out of time. I'm very sorry. In the slide, you have the screenshot of the packages that we can visualize. Those packages have a very similar size, but a different sequence number. So inside, we will have the encrypted messages that we want to be able to visualize. And that's all for me. Thank you very much for your attention and your time.